Alright, so on 3.1 again, we're going over number 31. It says locate the absolute extrema on the closed interval 0 to pi, and f of x is e to the x times sine of x. Just to get an idea of what we're looking for, we graphed f of x, and I changed the window. I've got x min is -1 and x max is 4, so that's just a little bit to the left and right of our interval, so we can literally see the whole thing with not a ton extra on the sides. I changed the x scale also. Since we're dealing with radians, we've got pi, and we've got sine in our problem. I wanted my x scale to be pi, something with pi. That way all of these little tick marks on our x-axis are going to be in actually useful numbers. The y minimum I set at -5, and the y max I made up to 10 so that we could see the peak of the graph. If we only set it up to a y max of 5, it cuts off the top of the graph. So you can just mess around with your y mins and maxes until you can fit enough information on your graph. I left the y scale at 1, so every tick mark on the y-axis is a positive or -1, up and down. Okay. We should expect to see an absolute extrema at the peak of the graph, okay, because that is the point where we have a tangent with a slope of 0. Also, since this is closed, we know that there is a point here and a point somewhere over here wherever pi is. I'm not sure where that is. Somewhere there. Okay, so we just need to figure out our maximum and our minimum. We're going to take the derivative. So f prime of x equals. This is another product rule. So we're going to do u prime v. So u prime is still e to the x, and v is sine of x, plus u, which is e to the x again, times the derivative of sine, which is cosine. To find critical numbers, we set our derivative equal to 0. We'll have e to the x times sine x plus cosine x equals 0. I went ahead and factored out that e to the x. Okay. I put 6 sine x. Okay. Set each factor equal to 0, so e to the x equals 0, or sine x plus cosine x equals 0. Okay. Can e to the x ever equal 0? It's always positive, so this one's impossible. So next thing we want to do is say, where does sine of x equal negative cosine of x? Right? So if we think about our unit circle, between 0 and pi, where are sine and cosine opposites of each other? At what x value? So what, like theta? What? At 45 degrees, think about the unit circle, it's root 2 over 2 and root 2 over 2. But over here, the 45 on the other side, root 2 over 2 and root 2 over 2. So how many radians is that?
3 pi over 4.
Yep.
Yeah.
Okay, so theta equals 3 pi over 4.
What about 7 pi over 4?
Okay, 7 pi over 4 is here. Yeah, 7 pi over 4.
Yeah, you just
That would work.
So why does it not actually work, though?
Oh, wait, because this one's positive. Right?
Oh.
Well, they're still opposites of each other, right?
Yeah.
Yeah.
At that point.
Oh.
This just means they're opposites of each other.
Okay, but why wouldn't that work on there?
Say it louder.
Oh, pi and 0.
Oh,
Say it louder for the video.
It's not between pi and 0.
Yeah, our interval is 0 to pi. That's it.
Oh.
So this one is not between 0 and pi, so it won't work. But if this was 0 to 2 pi, we would have to do both. So I'm really glad you said it. Okay, so we're going to use theta, which in this case is x, equals 3 pi over 4. That is this spot right here. 3 pi over 4. Okay. If on your calculator you did second calc and you went to wherever maximum is, and you did your like left bound, right bound, and guess, it would give you whatever 3 pi over 4 is as a decimal. So our critical number is 3 pi over 4.
How do you know that there's not more? Oh, just by looking at the graph.
Yeah, by looking at the graph, there's one, and that's it.
What about the end?
Okay, there's one critical number. Endpoints are not the critical numbers.
Okay.
It's a good question. We always do test the endpoints if it says what are the minima and what are the maxima. And does it say that?
No.
Locate the absolute extrema. Extrema are mins and maxes. We want to know what is the absolute min and absolute max. So we do actually have to test. Okay, we want to know what are the y values. So this is the only critical number. So if we were doing like the step 1, 2, 3, and 4 from the other day, this is step 1. Step 2 is finding f of whatever this is, f of 3 pi over 4. So if we plug 3 pi over 4 in, what do we get? You've already got it plugged into your y equals, so what is it?
This is 7.46.
Give me one more decimal.
0.
F of 0 is 0. I can tell that from the graph. Okay, what is f of pi? 0 again. That means my graph is a little off. This is pi. That's 0. So when we plug in 0 or pi into our original f function, we get 0 on both of those. And when we plug in our critical number, 3 pi over 4, we get 7.460. Let's list all of our values. So we have relative minima and relative maxima. So all of our minima happen at the bottom points, those endpoints. The y value is 0. And that happens at x equals 0 and x equals pi. So you can kind of list them out together since they are literally the same spot. Is that also the lowest y value on our portion of the graph?
Yes.
Yes. So what does that mean?
Absolute min.
Absolute also.
Would that mean they're both 0 and pi, then the absolute would be like
Yes. Yep.
So-
Since both of these have the same y value, and they're both minima, and they're the lowest, they are both the absolute.
So it doesn't matter that the graph like overall continues on. It's just because of the interval that we're looking at that's
Yes.
helpful.
Only
for
care about the
problems.
interval that we are zoomed in on from 0 to pi.
Okay,
Alright.
makes more sense.
Relative max is the y value, 7.460 at x equals 3 pi over 4.
That's the absolute max.
And it is the absolute, yep. And that's what we cared about in the problem, was absolute extrema. You should always definitely say if it's an absolute min or an absolute max. And if you always list relative min and relative max in a column like that, then you can just point out what's absolute.